wants to. Hey guys, welcome back. So some of you might remember this Honda EX1000. This one was sent to me in the mail by Brenda. It was a non-running machine and had a lot of issues with it. I made a video on that, and of course by the end of that video this thing was running pretty well. Anyway, after publishing that video, Jim, who is a subscriber, offered to send me his EX1000. It is partially disassembled and arrived in these two boxes here. Now, the story behind this one was that it stopped making power 20 years ago. He brought it to the Honda dealer. They partially disassembled it and told him it needed a new stator and that it wasn't worth fixing. So Jim sent this to me really just to harvest some parts to make this one a little bit more perfect, which was the plan originally. But since it's here, I think it's worth checking out that stator to see if the original diagnosis was correct, because when he asked for the parts back, the dealer threw a fit. And that is a bit of a red flag. So let's test the stator. I've already got it up here on the bench. Visually, I don't see any problems, but let's break out the multimeter and see what that has to say. A lot of times when stators go bad, it's pretty obvious because when they fail, it's usually the insulation on these wires that fail. It creates a short and a hot spot. And that hot spot sometimes will show itself in a burn mark on the copper, or sometimes it'll just heat up the wire to the point where the lacing starts to break, or the paper, the insulating paper down these slots overheats and starts to burn. But in this case, I see no signs of that. The lacing looks great. The copper color looks great. Nothing is burned in here. Really, the only suspicious area is right here. The insulation, it doesn't look right. So potentially that is the point of failure. The other side looks equally as good. Lacing's intact, nothing's burned, but there is something a little odd here. Not quite sure what that is. So yeah, there are a couple things here that don't look quite right. Anyway, as far as how to test this should be a pretty simple stator. It's only 120 volts, so you got one main coil. You have a displaced excitation coil, and you have a DC charging coil. So there should be a total of 6 wires to test. But when you look at these connectors, there's actually 5 wires in each of these connectors. There's spots for 6, but the 6th one is not populated on either connector. So we have 10 wires here, 2 more there, and 3 more there. So that brings it up to 15 wires. But I think we can eliminate a bunch of them. These 3, they don't actually go to the stator. They seem to just pass through into this connector as well as the green wire. So that eliminates almost everything on here except for the 2 wires here on the left. And then that leaves us with 5 wires here. So a total of 7 wires. Anyway, I don't know the resistance on a stator like this. It's quite a bit smaller than I normally test. So I'm going to take a quick look online, see if I can find a wiring diagram, and even better, a service manual. Luckily, I did find a service manual for this generator, an EX1000, and in it, it has a lot of information covering a lot of revisions of the EX1000. And included in that manual, it had several wiring diagrams, none of which matched this stator. So that service manual, I think, may have been published before this revision was made. So I kept digging, and I did find a user manual that had the exact wiring that I'm seeing coming out of this stator. So I think this is the diagram I need. Unfortunately, I don't have the most up-to-date service manual, but it does list expected resistance values. And even though they differ a bit between revisions, they are kind of within a very similar range. So I think that should give us enough to go by, and the wiring diagram should tell us which pins we need to check. So let's start with the main winding. According to this, it should be on this connector, the pins on the top left and top right. And the color should be red and white, which it is. So let's check the resistance. It should be between 1 ohm and 1.3. And we're low. It's at 0.6, 0.5. That seems like an issue. Let's check it to ground. No connection. Let's check the condenser winding. It should be this bottom left to the middle. And the reading should be between 4.3 ohms and 5.8. So that seems good. Check it to ground. No issues there. And lastly, we'll check the DC main winding, which are the only two wires coming out to this plug here, which are the left terminals, the top and the bottom. And this reading should be between 0.3 and 0.4. We're at 0.4, 0.3, that seems good. Check it to ground. No issues there. And one last check, we'll just check between each winding, make sure the insulation hasn't failed between any windings. So I'm plugged into the main winding now. We'll check it to the DPE. There should be no connection. And there's not. Then we'll check it, the AC main winding to the DC main winding. And we have a connection. So that's the problem. The low reading I'm seeing on the main AC out is due to the fact that it's shorted to the main DC out. And yeah, the stator is definitely bad. I may have spoken a little bit too soon. The main winding for the AC output, it is bad. The ohms, they're too low. But the connection I saw between the AC main winding and the DC main winding, that's actually supposed to be there. There's no separate coil for the DC. You just have one main winding, and you have a couple taps coming off of it. And one of those taps is driving the DC circuit. So that in itself isn't a sign of a problem, but the low ohms on the main AC output, that is the issue here. So I'm tempted, just to steal some parts, move it over to the other machine and call it done. But these little generators, they have a lot of value. One like this, it's probably worth $500. In better condition, people are asking $700 or $800. And even one that's broken and not working like this, people are asking kind of in the $200 to $300 range. So it might be worth fixing. I don't have any money into this. So I think I'm going to get all the parts out of the box, see if I have everything I need to make a generator except for the stator. And if that's the case, I'll take a look on eBay and see if I can't locate a good used one for a reasonable price. Looks like I have all the parts I need to put this thing back together. So assuming I can find a used stator, I don't think there's going to be anything preventing me from getting this thing back together. Now, the engine, it looks pretty complete. I don't think this has been taken apart. The engine rotates fine, and it has good compression. So I think this will run, but there was some damage during shipping. The spark plug boot is broken, and the plug itself is also split right in half. So that does need to be fixed up. The tank looks pretty good inside, despite having a bit of fuel. There is no rust to speak of. So I think we're in pretty good shape, but before trying to locate and order a used stator, I want to hear this engine run. So I'm going to get this stuff back out of the way, get this fixed up, see if I can't get spark to the engine. And once I do, we'll try to fire this engine up. This ignition coil, it belongs to an EX1000. It actually came on that machine. I believe this coil is good. Whether it is or not doesn't really matter. This boot is what I'm after, so I'm going to take that off. We'll swap it out with the bad one. And I also have an extra plug. I had ordered a plug for the other EX1000 through the mail and got impatient, so I ended up going to the store and buying a plug, but I never canceled the one I ordered through the mail. So we'll get these two items installed. I've already double checked the gap and we're good to go. I'm not expecting this to have spark. Normally, when you have the kill wire from the coil disconnected, it'll bring spark to the engine. But this coil, it's a little bit different. There's no electronic ignition built into it. It's actually more of a points and condenser type coil, but this does not have a points and condenser on it. Instead, it uses this ignition module to basically ground out or open up the primary on the coil, which creates the spark. So let's try it without this module, and then I'll crudely wire this in and see if it brings spark to this engine. Yeah, and we get nothing. So I'm going to connect up that ignition module and try this again. And we got spark. Gotta check the oil. I'm willing to bet it was probably shipped without oil. Yeah, I don't see any oil. So let's add some oil and try to start it. All right, let's give this a try. I've got the fuel hooked up, haven't turned it on yet, so there's a good chance this carburetor isn't gonna work, but let's give it the benefit of the doubt and try to start it. It wants to. Nice. First start in 20 years, and that engine sounds great. So I have no reservations about trying to find a replacement stator. I've already checked eBay. There is nothing available, but I've set up some alerts. So if something becomes available, hopefully I'll get it in time. So I'm going to pause the video here, and with any luck, when I turn it back on, we'll be testing the new used stator. It only took 6 weeks before eBay sent the alert that someone was selling the part that I needed. And this stator, it seems to be the exact replacement for this bad one on the right. So the guy selling it, he was asking $200, including shipping. I offered him $150 and he took me up on it. So let's test it real quick, see if it's any good, and go from there. All right, let's start by testing the primary winding, which is what was bad on the old one. The old one had 0.5 ohms. It should be between 1 ohm and 1.3. That's perfect. We're at 1.1. Check it to ground. No issues. We'll check the DPE winding. On the bad stator, that actually tested good at 4.7 ohms. And this one is pretty much the same. And lastly, we'll test the charge winding, or actually the DC output. It should be between 0.3 and 0.4. On the bad stator, that's exactly where it was. And we're the same on this one. Check it to ground. We're good. And actually, I forgot to check the DPE to ground. We're good. And let's check DPE to the main winding. And there's no connection. So, yeah, this stator's good. Just going to take this opportunity to clean up this area a bit. I'm not going to have access to it again once I get the Powerhead on. You definitely want to be sure to clean the bell housing where the stator sits in here, because if you get rust, corrosion, dirt, it may not seat properly. Just want to point something out on this rotor. Actually, two things. The wires, they are coated in some sort of resin, and they're basically cemented in. And that's what you want to see on something that's built to last. Most generators don't have that, and these wires are free to vibrate, and they eventually break. You know, believe it or not, I don't see this too often. This is probably the fourth generator that I've seen with something like this on it. Anyway, I'm going to get the rotor loosely installed. This one is a little different than most. Usually there's a fan on the engine side. And this right here on the bell housing is the exhaust for that fan. This one operates in reverse. The fan's actually over here, and this is the air intake, and the blower is over here, actually forcing the air out through some ducting. Honda actually doesn't list a torque spec on the stator bolts, but they are 6mm and they do have a general spec between 70 and 100 inch-pounds. Usually on bigger generators, I go up to about 80 to 100. In this case, I think 80 will be fine. Now's a good time to pull the engine over. I've removed the spark plug so there's no compression. I want to make sure the rotor is not making any contact with that stator. And we're good. I think to lock this engine up, since it's a flathead, I can't really put rope in the cylinder because it's offset to where the spark plug is. So I'm going to pull the blower housing off. We'll get a wrench on the crankshaft on the flywheel side to hold things still and torque this down. I paused the reassembly just for a minute. Since the blower housing's off, it's easy to access some stuff over here to get it cleaned up. So I've been spending a bit of time just kind of getting some of the layers of dirt off. I mean, in the end, it's a 30-plus-year-old generator with rust on it. So it's not going to be perfect, but I want to at least knock off all the heavy stuff while I have access to it. While cleaning it, I noticed the governor spring. It is a bit stretched out. So that could cause an issue. The engine potentially is down on speed as a result, and it may not respond well under a load. So let's finish getting this together. We'll start it up and see how that governor is responding. Clean that up a bit. All right, it's the moment of truth. I've got the light connected as well as the kilowatt. The fuel is plumbed in. Now, I have the light turned off, mostly because this hasn't run in 20 years, and it also relies on residual magnetism. So I want to give this one the best chance possible of powering up. So once it's started, hopefully we see that pilot light turn on. And then I'll hit the switch, and with any luck, we'll have some light. I got worried for a second. It took a while for that pilot light to come on, but it came on and it makes power. We started at about 57 hertz, 101 volts. So I bumped that engine speed up to 61.5 hertz, and the voltage came up as well to about 121 volts, which is pretty good. But I maxed out that governor spring. There's no more adjustment on that. And on a brushless generator like this, usually you want a little bit more voltage than 121 volts. So that spring, I think, needs to be replaced or modified. But now I know that this thing works, we'll figure out what to do there. Also, the carburetor needs to be cleaned. The tins need to be cleaned and reinstalled. So I'm going to do that now. We'll kind of finish putting this thing together and then get it outside for a load test. Yeah, I'm not sure this one's coming off in one piece. This one I don't think is going to be too bad. In fact, a lot of the surging might be due to the fact I don't have an air filter installed. Yeah, and this looks to be in very good shape. But I'll clean it anyway, just to make sure. This is the main jet in the center here. And underneath that is the emulsion tube. There it is. There's a little bit of junk on there. And there's a jet here on the side. Before I remove that, I'm going to turn it in. And actually, that's not a jet, it's a needle. There is a little hole actually in front of the throttle plate. And that always supplies fuel, no matter the position of the throttle. So you can kind of fine-tune things with this. Let's see where it's at. It's 1 1/4 turns out. So that could also be used to richen things up a bit. And lastly, we have the idle set screw, which this generator does not idle, so it does not need to be driven through very far. In this case, it is actually setting the idle speed. It's making contact right there, which isn't a big deal as long as you don't drive this in so far that the engine can't slow down when it needs to. And this is the pilot jet. Meters the fuel for this adjustment, I believe, here. And there's usually a couple holes on the side. You can just see them. And this jet meters the amount of fuel that comes out of those holes on the side of the carb. That's pretty much it. Not much to this one, so I'm going to run through all the passages, make sure they're not obstructed, and soak this for a bit in the ultrasonic. While that carburetor was cleaning, I also spent a minute and just started cleaning up the generator itself. I also ran the airbox and backing plate through the ultrasonic so they'll be nice and clean, and thought I'd turn the camera back on for this. This foam filter is by far the worst I've ever seen. These do degrade over time and they get flaky, which is obviously not good, but this one kind of takes the cake. I mean, it is just completely crumbling. So if you have a foam filter, definitely pay attention to it. I would say they last, well, I guess it varies, but I'd say about 10 years is the max you get before something like this starts to happen to it. Anyway, I'm going to run this through the ultrasonic as well, and then we should be ready to put this thing back together. It cleaned up pretty well. It almost looks like new. Hopefully it runs that way. Half one. I'm going to do 1.5 to start with. It was 1.25 before, but since it was running lean, I think we'll just give it a little more to start with. That should be fine. Just a couple threads sticking out. Fortunately, this governor spring is discontinued, which is surprising. A lot of parts are available for this engine, but not this spring. I did check eBay, nothing on the used market either, so replacing it, it's not an option. Potentially I could modify it by shortening it a bit, just moving this bend over about 1/4 of an inch. But this is spring steel and it does not look to be in good shape, so I'm kind of worried about trying to move that bend. Most likely it's going to break. I've tried it before using heat, and that does allow you to bend this, and I did it successfully, but I put it back on the generator, brought it outside, and started it, and it ran for about a minute before it broke. Well, that was odd. Just shut down. So in this case, I think the path of least resistance is to put a longer screw in there. Right now it's maxed out, but you can see this has a lot more travel. So if I put a slightly longer screw in there, that'll give me the adjustment I need. I mean, right now I'm pretty close. It's around 61.2, 61.5. Ideally, I would have this up to about 62 hertz with no load and a little bit of extra room, in case someone needs to adjust that in the future. So let's pull that out. I'll put a slightly longer one in, and hopefully that'll do it. I'll leave it right there for now. We'll adjust it when the engine's running. Usually the drain bolt on these carburetors go opposite the fuel inlet, but not this one, or else you won't be able to access it. So I loosen the bowl. I'm just going to rotate it so that that drain bolt is pointing toward the starter recoil. Going to drop the tank in next. I drained the fuel, put a little bit of fresh stuff in there, and tested the fuel flow. There's no obstruction, so we should be good. As far as how to install this, the tank actually just drops in and sits on top of the engine. It's the outer coverings that actually secure the tank in place. But before I secure it, I need to connect the fuel line and the on-off rod for the fuel valve. Both are right here. Kind of hard to show you, but that's what I'm going to do. And then we'll finish getting the skins on and we should be good to go. Surprised I made it this far, but I'm out of hardware. I am missing a bolt here, and the panel on the right requires 4 of these screws, and I only have 1. So I do need to make a trip to the hardware store, and I'm still waiting on the air filter. So when I get that stuff, we'll finish it up. I found a bolt that fit. It was an M6, And I swapped out the OEM that was not missing just so that we have a matching pair. As far as the air filter goes, that came in today. It is pre-oiled, so no need to oil it. And I picked up 4 bolts for that end cover. I took a second just to paint them up, but I'm going to leave the end cover off for now, because once it's running, most likely I need to adjust the jetting on the carburetor, as well as the engine speed, and it'll just be easier to do with that side cover off. Let's get it started up. I'll set the engine speed to 62 Hertz, and then load it to 750 watts, let it run for a bit, and make sure there's no surprises. I'd say the carburetor issues are sorted out. The engine started right up, and I turned the choke off right away, and things ran pretty smooth. Now, the engine speed, it was down a bit, but that's because I replaced the adjustment screw for that governor spring. So I brought the speed up to 62 Hertz, loaded it to 750 watts, and that engine speed, it sagged too much. It was at, I'd say 56.7, maybe 56.8 Hertz, and ideally, you don't want that dropping below 58 Hertz. If it does, then it's one of two issues. Either the engine is down on power, or there's an issue with the governor spring. And in this case, I know we're not down on power because I bumped the throttle manually, and I had no problem getting the engine speed back up. And as we saw earlier, that governor spring is damaged. So, is it unusable like this? I would say no. But ideally, I would replace that spring. So to that end, I know I can't buy a new one, but I did reach out to the seller who sold me that Stator. He is parting out one of these machines, and I asked him if he had the governor spring for an EX1000, and he did. Now, this spring, I wouldn't say is in great shape either. It is stretched out a bit, but not as bad as the one that's in there. So I'm going to swap out the springs or reset the no-load speed and try this again. This might be hard to do with the airbox installed. All right, let's try it like that with the airbox off. I don't want to make anything permanent until I know this one's better. Swapping out that spring definitely made the difference. The old one, it was stretched out and not really up to the task. And granted, the new used one I put in there was also stretched out, but it is doing a better job. It's holding the engine at 58 hertz under the same load, about 125 volts. So I think that's good. So I'm just going to finish it up. I'll throw the end cover on and call it. I think that's a wrap, guys. I mean, this thing, I'd say I got pretty lucky on. It broke over 20 years ago, and thankfully, Jim thought enough to save the parts on the off chance that he could get it repaired someday. And, you know, his intention was to just send this to me as parts, but it only needed one part, really, to make this thing complete. So, luckily, I found that part, and this generator lives again. So, I hope this video helps someone. Thanks for watching.